Okay, this is 3.5, and this is factoring polynomials in the form x squared plus bx plus c. This is one of the more important lessons in pre-cal 10. It becomes very useful if you're going off into pre-cal 11 and also foundations 11. First thing we're going to do is we're actually going to review expanding. There's two ways you were probably taught this in grade 9. One of them is FOIL, which is first, outside, inside, last, whatever you want to remember. I just call it expanding. But basically what you're going to do is you're going to take your first term and multiply it by every term in that second bracket. So x times x, and then x times 7. So x times x is x squared, x times 7 is 7x. You take your second term, 3 times x, and 3 times 7. So 3 times x turns into 3x, and 3 times 7 is 21. You're then going to combine all your like terms. So there are no other x squared terms, and we're going to start with our biggest term first. So we write x squared first. 7x and 3x combine together to give me 10x, 7 plus 3, and we're going to have a positive 21 at the end. Again, you're basically going to make sure you multiply every term by every other term, and then you're combining out like terms. Another way some have shown this was called the square method, which is you draw a square with 4 quadrants in it. If I have x plus 10 times x minus 3, I take that x plus 10 and I put it on this top row. So x goes in the first column, and positive 10 goes in the second column. X minus 3 goes x in the first column, or first line, and then negative 3 in the second line. I then do the same thing. What is x times x? Well, that is x squared. X times 10. That's positive 10x. Negative 3 times x is negative 3x, and negative 3 times 10 is negative 30. The order in which you do this is the exact same. You can use FOIL or expanding or the square. You'll get the same answer. When you combine like terms, again, I'm going to start with my biggest term, so I have x squared first. I've written that off. 10x and negative 3x, when I combine those together, 10 minus 3 turns into positive 7x, and left over is negative 30. I don't really care which way you do this. Usually simplicity-wise, I like to just FOIL and expand it just because it takes up less room, and I can usually do it a bit quicker, but both methods work just fine, and you're welcome to use whatever method works best for you. Again, this should have been done in grade 9, but it can't hurt to review it. If I add a coefficient or a number from my unknown, it doesn't change the process whatsoever. 5x times 2x. 5 times 2 is 10, and x times x is x squared. 5x times 1 is just 5x. 3 times 2x, well, 3 times 2 turns into 6x, and 3 times 1 turns into 3. Again, combine all my like terms. So there's no other there's no other x squared terms, so I leave that alone. So I get 10x squared. 5x and 6x I can combine, both positive, so that turns into 11x. My last term is plus 3. So the coefficients don't change anything you really do, it just adds a few extra steps. The order doesn't really matter either. I can have my numbers in front or numbers behind. So if I go negative 3 times k, I just get negative 3k. Negative 3 times negative 3 turns into positive 9. K times k turns into k squared. and k times negative 3 is negative 3k. When I combine, just like last time, you want your highest degree of polynomial first. In our case, anything that's squared. So we're going to put our k squared first, followed by our k's. So we have negative 3k and negative 3k. When I combine those together, I get negative 6k. And last but not least, I have a positive 9. So the order at which I do this, it doesn't really matter at all either. Okay. Again, most of that was reviewed from grade 9. Now we're going to get into the grade 10 material. So, factoring is basically the reverse process of expanding. It's going from this and finding out what your two factors are. It's what we call an inverse process. I can go one direction, I can also go backwards. You can go either which way. It doesn't really matter that much. There's a pattern to doing this, and a little bit of a trick. Okay, we will still call these simple trinomials. We'll get into that later on, because a simple trinomial does not have a number in front of x squared. A complex trinomial will, but that's about 2 or 3 lessons away. The trick when doing these is we must find two integers, either a positive or negative whole number, that add up to our middle term and that multiply to our last term. In our case, they add up to negative 2 and they multiply to negative 8. Again, the numbers will change for the example, but the terms will not. So you're always going to add up to your middle term and multiply to your last term. That's the important part. It's also why we spent so much time learning about factors of different numbers and how to find those common multiples and whatnot. So to start this out, we're going to write out all the factors of negative 8. So I've done that here. So I've got negative 8, I'm going to write out, and I have 2 times negative 4 gives me negative 8, negative 2 times 4, 1 times negative 8, and negative 1 times 8. I want to include both my negatives in there. I then add all these up to see which of them add up to negative 2. And it happens for us, our first term, 2 plus negative 4 gives me negative 2. Negative 2 plus 4 is positive 2. 1 plus negative 8 is negative 7. And negative 1 plus 8 is positive 7. What we care about is these terms, 2 and negative 4. Because we know that when multiplied together, they give us negative 8. And when added together, we get negative 2. We're then going to take those two terms and put them into our formula, which is basically x and one of our integers with x, another one of our integers. Please note the x can change. It's only x because it's x squared minus 2x. If this was like k squared minus 2k, then these would then be k. Just a formality. The nice part is you can always check by expanding. So we're going to take our first integer, we're going to go x, and I'm going to go positive 2 times x, and our second integer, which was negative 4. And again, just like we did with simple factoring, we can always check our answer by expanding, which, if you have lots of extra time on a test, it's never a bad idea. X times x is x squared. X times negative 4 is negative 4x. 2 times x is 2x. 2 times negative 4 is negative 8. Again, we combine and simplify. Our biggest degree is x squared. Negative 4x plus 2x is negative 2x. And last but not least, we have negative 8. Which, if we look at that and look at our first answer, they are indeed the same. So, we'll do this again step by step, and I'll go a little bit slower. So, we're going to factor x squared minus 12x plus 35. The numbers in the middle don't really matter. What we care about is we have to realize we have to add to our middle term, we have to multiply to our last term. The way we're going to do this is we want to find out all the multiples of 35, both positive and negative. So I remember that 35, 7 times 5 gives me positive 35. Negative 7 and negative 5 also give me positive 35. I have 1 and 35, negative 1, negative 35. I believe that's it. I can again go through this, and again, I don't have to write that big chart. I can just kind of add them up as I go. 7 plus 5 is 12, not negative 12. Negative 7 plus negative 5, however, is negative 12. And once we've found our two factors, we can stop there. So, I'm going to write x, and one of our integers, so x minus 7 times x minus 5. This takes a lot of practice, guys. I strongly recommend doing the textbook questions for this one. You really want to make sure you understand how this works, because you want to be able to do this pretty quick. And really it just depends on how quick you are at kind of mental math when it comes to finding factors and products of two different numbers. The homework for this is only going to be 2 questions. The first question is you're going to factor x squared plus 5x plus 6. And I'm also wanting you to expand x plus 11 times x minus 3. And again, if you have lots of extra time, this is one of the ones I'd really strongly recommend doing the extra textbook questions for. It won't help you out this year, but it will definitely make life easier next semester. Normally what I would assign is on page 166, questions 5, 9, 10, 11, 12, 14, and 15. Again, these ones will not be for marks. Maybe try 1 or 2 of them. If you understand the basic process of factoring, you should be okay. This is kind of a big unit, especially for those going to pre-Cal 11. If you have any questions, I'll be available on Tuesdays and Thursdays. Good luck.